Okay, so first we start with step one of glycolysis. So in step one, we start, as I said, with glucose. Let's draw the structure here. Good way to remember this structure is you start with your CH2OH group with an H at the bottom, and then you alternate hydroxyl groups until you get to the end, which will have a repeat. That's how I remember my structure of glucose. So the first step is an irreversible step. It's going to require ATP as part of the energy investment phase, and it'll produce ADP. It also uses a magnesium 2 plus cofactor. And this step's pretty simple. All that's going to happen is that OH right here is going to get converted into a different functional group. Different functional group called a phosphate group. And everything else about your product will be exactly the same as before. And because of this, since this is the carbon 6, we are adding a phosphate group. We're going to call this new molecule glucose 6-phosphate. And one other important thing to note about step one is that it's going to be catalyzed by a very important enzyme, which is called hexokinase. So kinase is an enzyme that phosphorylates a substrate. And hexo, I think of as the 6-carbon structure of your glucose. That's how I remember the name hexokinase. Okay, so now we're going to get into step two. So I've redrawn the glucose 6-phosphate. This time I drew out the entire phosphate group. You'll notice there's 2 oxygens singly bound to the phosphorus and 1 double bond. That gives you a 2 negative formal charge. So in step 2, it's going to be a reversible reaction this time. So we're going to indicate that with these arrows here. And there's no ATP used in this step, nor is there a cofactor. Instead, we're just going to use an enzyme called phosphohexose isomerase. So just from the name of this enzyme, we can tell again there's going to be a hexose. That's again a reference to the 6 carbons in our substrate. Phospho is a reference to our phosphate group right there. And isomerase tells us that this is going to be an isomerization reaction. So what happens is we go from glucose to fructose. And remember, it's an isomer, so we're going to still have fructose 6-phosphate. And the structure for that is going to be relatively similar. We're just going to draw a 5-membered ring instead of a 6-membered ring. Going to keep our phosphate group where it is. And then I kind of just go around and make sure everything looks the same. So the next after this carbon that we already drew is this one. So we're going to make sure that our OH is still pointing down and our H is still pointing up. And I keep going around, the ring and continuing that same process when I draw my product. And finally, to keep our 6 carbons, we're going to put 1 up here and keep our alcohol right there. So now we're going to move on to step 3, where we still have our fructose 6-phosphate. And this is an especially important step. This is another irreversible step that we call the gateway to glycolysis. And we call it that because this is the first committed step of glycolysis, which means that once this step happens, the rest of the reactions in glycolysis will happen. So like once again, we're going to take 1 ATP, convert it into ADP in this reaction, magnesium 2 plus cofactor, and our enzyme, this is a very important enzyme, is called phosphofructokinase 1, or sometimes you'll see it PFK-1. Again, I think it's important to recognize like how the enzyme names relate to what's actually happening in the reaction. So we can see phospho again, we have our phosphate group once again. Fructo, it's a fructose. And kinase, again, that means that there's going to be a transferring of a phosphate group, which we will see in our product. So our product, once again, similarly, is going to be almost the exact same structure as last time. So we'll just redraw that. Right. The only difference now is instead of having this OH, we're going to replace it with another phosphate group. So then the name of this molecule is still a fructose, but now there's phosphate at the 1 and the 6 positions. And we add a bis before the phosphates to indicate that there are 2 phosphates. All right, so after our committed step in step 3, we have step 4. And step 4 is very interesting. It's, again, this is a reversible reaction, and it's going to be catalyzed by an enzyme called aldolase. And this one, the enzyme doesn't really relate to the name of the substrate very well, but it does tell you exactly what kind of reaction that happens, which is an aldol reaction. That's important to know. So we're actually going to have 2 products because this is going to cleave our ring. So one of our products, each of our products will have 3 carbons in the structure because we're taking the 6 carbons in our initial molecule and we're splitting it into 2 in an aldol reaction. So one interesting thing about this reaction is we're going to have 2 different products, as I said, but they're actually going to be 2 distinct products. So our first product is going to have a carbonyl in the middle. It's going to still have our phosphate group, and it's going to have an alcohol at the bottom. We call this dihydroxyacetone phosphate. And our second molecule is going to be called glyceraldehyde 3-phosphate. Right. So easy way to remember this, of course, there's an aldehyde in the name. So we're going to draw an aldehyde functional group. It's easy enough. We see 3-phosphate. This is known on the 3rd carbon that there's going to be, we're going to have another phosphate group. And finally, remember that well, I'll get to that later. So for our other carbon, we're going to have our alcohol. So you may recall that these are our 2 products from step 4 that we're going to involve in step 5. The name of this one is glyceraldehyde 3-phosphate, and of course we have our dihydroxyacetone phosphate. So of course we had 2 different products in our step 4 reaction, as you can see. And what we want to do when we continue this pathway is we want to convert it into just one of these 2. So what happens is our dihydroxyacetone phosphate is going to be converted into glyceraldehyde 3-phosphate so that we will have ultimately 2 of those. And this happens by an enzyme known as triose phosphate isomerase. So again, this is an isomerization reaction, as you can see by the name. The triose phosphate, this triose indicates the 3 carbons in each of these molecules, each of these sugar molecules. And the phosphate, of course, is a reference to the phosphate group, once again. So in this way, we now have 2 of each of these molecules that are going to continue the path down. That's going to become really important that there are 2 of these molecules, the glyceraldehyde 3-phosphate molecules created per glucose.